for the session TrustKit Code Injection on iOS 8 for the Greater Good with our speakers Alban Decay, Eric Castro, and Angela Chow.
Thanks. Hi everyone, thanks for coming this early at our presentation about something we're very excited to release called TrustKit. So my name is Alban, and with Eric here, together we are working at this company called Data Theorem, where we've built a tool to automatically find security and privacy issues in mobile applications. And Angela here is part of the security team at Yahoo. And so today we're releasing a new library for iOS and OS 10 apps called TrustKit. So first we're going to kind of describe what this is, why you may want to use it in your apps, and then we'll kind of go into the details of how it actually works, why it's novel, why the implementation is interesting, and all the things, how it works and all the things that happens behind the scenes as you're using it. But first of all, TrustKit. So our goal initially, which sounds pretty simple, was to create an SSL pinning library for iOS. And as we started working on that, we really wanted to make sure that that library was going to be usable in real apps with lots of users, strong requirements like battery life and performance. And overall make sure that this is something developers will be able to use and not some idea or proof of concept. And to get there, we had the opportunity to work with the Yahoo mobile and security teams. And Angela here is going to talk about her challenges when trying to deploy SSL pinning at Yahoo.
Thanks, Alvin. So SSL pinning, let's see. It's been talked about for years, and pretty much everyone in the security community agrees that it's a good thing to do. And I mean, like, who wants to trust hundreds of CAs where some of them are compromised, others are government-owned, and yet others that are dubious? And in the mobile app world, it's the perfect place to do pinning because you own both the client side as well as server side of the communication. So I thought, well, this is a great project to do. And when I first started to do cell pinning for Yahoo mobile apps, I thought it would be an easy, straightforward project. Maybe just add a few lines of code to check for the right certificate, and that's it. Or so I thought. Until I hit into some technical challenges, as well as operational challenges, as we shall see. So first of all, what should we pin? Is it the certificate or the public key of the certificate? As we all know, certificates are often reissued with different extensions or expiration dates, so they're a little bit brittle to print to. And public key is better because it's not going to be changed as much. But even just the public key bits are not enough, as we also need to know the algorithm that the public key is associated with. So together, the algorithm, as well as the public key bits, they're called SPKI, or the subject public key info, and that's what we should really be pinning to. However, unfortunately, in iOS, there's no API to really extract the SPKI from a certificate. So I started looking all over the web for examples, libraries, and just to see how other people are doing mobile pinning. And I couldn't find one that used SPKI at all. In fact, most of them are just comparing the whole certificate itself. And then another challenge I hit on is how am I going to implement this? I don't want to go and find and modify every single instance of NSURL connection and NSURL session in all of the mobile apps that we have. And so I thought I'll be smart and use method swizzling. So I only need to do it once, and all the mobile apps would get it transparently. That is until I hit upon another problem, which is in UI web view, it's not using NSURL connection or NSURL session, and so therefore method swizzling would not work. And so we need to intercept the code at an even lower level. And finally, on the operational challenge side, is like, how do I get buy-in from the product team? Blocking attackers is a good cause, and we do want to protect the user's data. But when you go to them and say, you have this great idea that you're going to block user connections, they're understandably a little nervous and say, which users? Or how many users are we talking about? And I don't know. Or what if we block the wrong connections? And so with that, we thought of a solution, which is to have a report-only mode. That way we can gather the data first to see what we would have been blocking before we actually enforce the blocking. And so business can decide with the data that they gather whether this is a good decision or not. And so there's no existing iOS library that does all these 3 requirements that I need. And I thought I probably would have to write my library from scratch until I met up with Data Theorem and I started telling them all my challenges and how I need to start this project, and they got interested. And so they say, why not start a collaboration project? And so here we are. So back to you, Alvin.
Thanks, Angela. So yes, we started collaborating, and all in all, we basically solved all these challenges. One thing was having a library that works on all your network connection on all the APIs. And we have that because the way we did it, if you look at the Apple network stack, there's a lot of different APIs you can use to do network connection, low-level APIs like BSD sockets, to higher-level API like NSUR session, where you can do HTTP connections. What's interesting about that is for anything SSL or HTTPS, they all use secure transport. Secure transport, which is the one on the bottom right, is Apple's SSL stack, Apple's SSL implementation. So all these APIs, all the APIs you can use, they all use secure transport for SSL. So what we've done is we've extended secure transport with our library called TrustKit. And so we've added that SSL pinning functionality to secure transport. And once you do that, basically all the APIs can take advantage of that. All the connections are protected. And you'll see that in the demo. But so basically it works on all the Apple APIs kind of transparently. You don't have to do anything. You don't have to find all the instances of NSUR connection. Then the other thing is it's very easy to deploy. You just set your pinning policy in the app's manifest. So that's how it looks like in Xcode. You just put the domains you want to pin, your SPKI hashes, some other settings. And it's all heavily based on HTTP public key pinning, which is a specification for browsers. So we've kind of done the same thing, but on iOS. So you have all these settings, and once you've put that in the manifest, you're done. So that's pretty easy. And then so we have SPKI pinning. As Angela said, there's no way to pass a certificate on iOS and get the SPKI, so we just have to ask the developer what the key algorithm is. There's no way around that, unless you want to write your own ASN1 parser or something. So that was the best solution. And lastly, we have a report-only mode. So it's just like also the HPKP spec. If your app somewhere on the device sees an unexpected certificate chain, it'll send you reports, and they look like that, which will tell you kind of what's going on, the certificate chain that was seen. And so it'll give you a global picture of people seeing, or users seeing bad certificate chains in the world. So we've solved all these things. That sounds pretty cool, but the right way to really see that is with a quick demo. So we have a demo of that. So it's basically, on the left you have a real phone with the burp CA pre-installed. So the burp CA is already trusted, and on the right you have burp set up to proxy all the phone's connections. So the usual kind of man-in-the-middle setup. And with that, I have in Xcode an iOS app, a very simple iOS app called TrustKit Demo. And I'm just going to build it and install it. And what it does, it's just a web view, and you can put a URL and connect to it. And so right now, when you connect to it, you can see all the traffic in burp because there's the whole setup working, and the burp CA is trusted in the app. So that's expected. And now I'm going to deploy TrustKit, and you'll see it's pretty quick. So the first thing I'm going to do is drag and drop the TrustKit Xcode project in the app. And then I have to tell Xcode that I want to actually embed TrustKit into the app, so you have to add the framework. And then the last step is just setting up your pinning policy in the app's manifest, in the info.to list. I've already set it up, so I have it. I'm just going to paste it into the manifest. And it all has to go under a key called TSK configuration. And inside that key, you can configure your pinning. And in that case, I have something for datatheorem.com, and I'm pinning all the subdomains, and I've set up all the hashes, the public key, SPKI hashes. And I also have a report URI, so reports are sent to this server if something goes wrong. So that's it. I'm going to rebuild the app, clear the history in burp, and restart the app. And now I'm going to try to connect to datatheorem.com again. And when I try that, you get an HTTPS error. And you can't see anything in burp. And then in the logs, you can see that TrustKit was checking the certificates, trying to find these pins, and didn't find them, so it returned an error. The only thing you can see in burp is the actual report that was sent, because it was an HTTP URI. So it's the report sent to my server to let me know that something wrong happened. And that's pretty much it. So that took, I don't know, 1 minute. And now you have SSR pinning in your app for all of your SSR connections. And you can use it now. We open sourced it this morning. And it also works in Mac apps, OS X apps. We'll talk a bit more about TrustKit at the end. But for now, we'll kind of give more details about how it actually works behind the scenes. And what's interesting about it is that we've used techniques that usually are used on jailbroken devices, because we're doing things like C function hooking, insecure transport, and other things. And the other thing that's interesting is it could be applied to other problems than SSR pinning. And to take a step back, how this whole idea started was that when iOS 8 was released, one change we noticed was that Apple started allowing dynamic libraries to be embedded in apps. And Eric and I have a lot of experience working on tools called CDR substrate tweaks, which also are dynamic libraries to modify apps on a jailbroken device. So it's used to kind of customize your phone if it's jailbroken. And it's also used in security, where you have a lot of security tools that are based on CDR substrate. I've worked on some of these, like SSR kill switch, tools to make it easy to reverse engineer apps and kind of try to understand how apps work. So we kind of made that connection where, okay, now dynamic libraries are allowed. So would we be able to use the same techniques, like CDR tweaks, on a non-jailbroken device in a normal app? And now Eric is going to talk about what it really means to have dynamic libraries in iOS 8.
Thanks, Alvin. Hi, everyone. So before iOS 8, the only way that applications interacted with dynamic libraries would be with those that were pre-installed in the system, like the Apple frameworks like UIKit or Core Foundation, a few Unix libraries like SQLite or zlib. So if we wanted to create our own libraries, the only thing that we could do would be static libraries. And this was enforced by the App Store review process, because at that time, Apple didn't really have a reason to allow dynamic libraries, because applications would consist of only one single executable. And because of the sandbox, there would be no way that applications could interact with other applications through shared code, through a dynamic library. But now that has changed in iOS 8, because Apple introduced app extensions, which allow developers to create functionality that is outside of the application context. So now you can create these things like widgets for notification center or custom keywords, Apple Watch extensions or photo filters. But none of these are part of the main executable. These are separate executables. So it made total sense that Apple would start allowing dynamic libraries, because especially now that they're caring so much about the application size on disk, and you can see that as well with iOS 9, with features like app thinning, app slicing. So dynamic libraries help reduce the application size when you have several executables. But we saw that it's not really necessary to implement an extension if we want to use a dynamic library in our project. So that's what we did with TrustKit. So you could see if you saw in the demo, we just drag and drop our framework to our project, and what's happening behind the scenes is that so a dynamic library dependency is being created in the Mako binary that we're building. That's our app, and it's creating a load command structure. So if you've done some reverse engineering or security research in iOS or OS 10, you're probably familiar with the Mako file format, which is the one for iOS and OS 10. The executables have this layout. And so the executables are going to interact with the dynamic linker, which is called ILD, which is going to be responsible for loading our libraries at runtime. And then, because we're in a sandbox environment, Xcode is going to package our dynamic libraries within the apps bundle. And the way ILD is going to find them is going to use a couple prefixes in the load command structure. One of them is, for example, the executable path, which points to the full path in the apps. It's the app folder within the device inside the sandbox, and then there's the rpath prefix that allows for multiple search path locations for libraries. But then again, because we're in a sandbox in iOS, this is limited to only one single location, which is a frameworks folder that is created by Xcode when we build our app. And so if we check our application in a tool like Mako View, which allows us to inspect the Mako structure of our binary, we can see that we have our load command, our load dylib command referencing our TrustKit library. And so we see the path, so it's located in the typical .framework folder. And then if we replace the value of the rpath prefix with the contents of the load command, the rpath, we can see that indeed there is a frameworks folder that it's inside the executable path. Again, that's the .app folder that it's in the device, the full path to it. So cool, we now know how libraries are loaded in iOS 8, which is no different from OS 10, but this is kind of new in iOS 8. And then we needed something to initialize our library. So we can make use of something that is called the constructors. Dynamic libraries can have constructors, which is basically a C function that it's called when the library gets loaded by ILD in memory. So, and because this function gets executed before the app starts, it's the perfect place to initialize our hooks or patches or replacements. And if we had any settings, we can use this to initialize our settings. So if you look at the fourth bullet point, that's what it looks like. It's just a static C function with the constructor attribute. So to make a quick recap, when we added this dependency on our project, we're creating this load command that will basically allow the dylib to get automatically loaded when the app starts. And then there's going to be the constructor that is going to get called right after that. And so basically, this whole thing takes care of the injection process of our library, which is different from what we were used to in our jailbroken environment. So now we can solve that with just the dependency mechanism. And then the only thing that was left is, okay, so we need to hook into functions, into C functions, which again is different from method Swissling because again, with TrustKit, we're trying to make modifications in secure transport, which is a C API. So now Alban's going to tell you about a couple of alternatives that we use and the problems that we had and how we solved it.
Thanks, Eric. Yes, so function hooking on a non-jailbroken device. Again, C function hooking, not method Swissling. We tried a few things. The first obvious attempt was to just try to package a CDR substrate tweak into an app. So I just used an existing tweak that I've worked on called SSL kill switch. And so you kind of have to make some modifications, package it into the app, embed CDR substrate, code sign, the whole thing. There's some setup, but then you can get an app that's loading a tweak. But once you try to start the app, you get a crash. You get a CKIL code signing. And if you look at the stack trace for the crash, it's at the very beginning of when the app tries to get started. You have a stack trace, and in the stack trace, you have Basically, the first thing is the dilib constructor, the Twix constructor. And then it's calling MS function hook in CDR substrate. And it crashes when you call MS function hook. If you've used CDR substrate before, MS function hook is the function you use to replace C functions. So let's say you want to replace malloc with your own implementation. You would use MS function hook to say, okay, replace malloc with this. So when you call it on a non-jailbroken device, it crashes. And the reason for that, without going into the details, is basically the way substrate hooks C function is by actually modifying the very beginning of the function in memory. So it replaces instructions so that when that function gets called, it actually jumps to your own implementation. So basically, it's self-modifying code, which is not something you can do on a non-jailbroken device, because you need memory pages where you can write code and then execute it. And there's a safety mechanism that won't let you do that. Won't let you do that unless you're running in a debugger. So just so you know, if you ever need to run a TDR substrate tweak on a non-jailbroken device, you can, but you need to be running in a debugger. But for a normal App Store app, it's not going to run in a debugger. People downloading the app are not going to be running it in a debugger, so there's just no way. And that first attempt failed. There's no way to package a tweak into a normal App Store app. Something else we tried, it's kind of a well-known technique, DLD install libraries. So it's an environment variable, just like LD preload on Linux, where you can get your library to load and say, okay, I want to replace these symbols, for example, again, malloc, with my own function. So it's symbol rebinding. It only works with exported functions. So you cannot modify a function that's private to the app, that's inside the app. But any of the dependencies where there's like symbols, you can replace them with that technique. The problem with an environment variable, is that you cannot set an environment variable in an iOS app. You can in Xcode when you're testing your app, but again, people downloading your app on the App Store, there's no way you can set an environment variable. So basically, there's no way to use that either. And then the last attempt is that it turns out there have been some new libraries that were released that also do symbol rebinding, just like DLD install libraries, but at runtime. So it's dynamic symbol rebinding. There's one from Comex called Substitute. And Substitute does many different things. It can hook functions just like Substrate by actually patching the function memory, but it also has one specific function to do that interposition, which is going to work on a non-jailbroken device. And the other one is from Facebook called Fishhook, and it's the same thing. And if you actually try to use these on a non-jailbroken device, it actually works. So you're able to modify, replace symbols, and make changes to the app. And so going back to TrustKit, now it's kind of the recap of how it really works. When you add TrustKit to your app in Xcode, it puts the dynamic library into the apps package, and then it adds a load command to your app, so that when the app starts, TrustKit is also loaded. When TrustKit is loaded, it has a constructor that's defined, and so that constructor gets run. And what it does, it gets the pinning policy from the manifest, and then it sets up some hooks in secure transport. And specifically, it's extending that function called SSL handshake, which obviously takes care of the SSL handshake. And so it's extended to do SSL pinning. And for patching that function, we're using Facebook Fishhook. And that's why, as you saw in the demo, the only thing I had to do was to just drag and drop it. And I didn't actually change the app source code. This was just all taken care of. So that's how it works. So you should try it out. It's open source since today, very open license. It works on iOS and OS 10, and it's already on the App Store. It's not a proof of concept. It's not an idea. It's live on the store right now in one of the Yahoo apps and another app as well. And we're working with other companies who are interested in using it as well. The more people use it, the better, so you should definitely try it out and let us know what you think. And hopefully it'll be useful to you as well. And that's it. Thanks, everyone. So we have like 20 seconds. I don't know if we have time for a question. But come talk to us at the end if you want to know more. That's fine. And since I have 15 seconds, there's one last thing. If you need to do security research on an app that's using TrustKit, I also released a tool to disable TrustKit on a jailbroken device. So it's called SSL Switch 2. So don't spend days trying to bypass it. I've already done it. Again, it's on a jailbroken device, so it's not the threat model of SSL pinning. So that might be useful as well. All right. Thanks, everyone.